Vertical circular motion. This is the picture of vertical circular motion. If you take any kind of stone or a rigid bob and tie it to the string and whirl in front of you, you will get such kind of motion. In this motion, the weight of the bob, it is always acting downward direction, and the force due to the tension along the string, they are acting towards the center of this circular path and balances centripetal force. So you will get such kind of motion in a vertical circular motion. Here the bob is moving along the vertical circle. The speed may be remain constant or it may be non-uniform. There are two types of vertical circular motion commonly observed in practice. First is controlled vertical motion. For example, giant wheel or similar games. In such cases, we can control the speed of these wheels. We can increase the speed, we can decrease the speed, or we can keep it constant. So we can say that in this case the speed is either kept constant or not totally controlled by gravity. The second type of this vertical circular motion is the vertical circular motion controlled only by gravity. Now in this case, we initially supply the energy at the lowest point and then onwards there is entire kinetic is governed by the gravitational force and it start whirling in a clockwise direction or anti-clockwise direction. Here, when the object is moving from bottommost point to the uppermost point, its kinetic energy decreases and potential energy increases. And from when the object is moving from uppermost position to the bottommost position, its potential energy decreases and kinetic energy increases. So we can say that during this motion there is an interconversion of kinetic energy and the gravitational potential energy. So consider the first case of the vertical circular motion which is controlled only by gravity. That is, a mass is tied to the string. So this figure shows a bob is, is tied to the massless, inextensible and flexible string. Here the bob, whatever we have considered, it should be a point mass. It is whirled along a vertical circle so that bob performs a vertical motion and the string rotates in a vertical plane. So this is a vertical plane and the string rotates in this vertical plane. At any position of the bob, suppose the point A, point B, point C and point D is shown the position of the bob at 4 points. So there are only two forces are acting on a bob. One is its weight mg vertically downwards and which remain constant. And second is the force due to tension along the string and they are directed towards the center of the circular path and it is always balances the centripetal force. Its magnitude changes periodically with time and location. Consider the vector diagram of a mass tied to the string and assume that it is performing a non-uniform motion. So, the resultant of the two forces, that is mg force and the tension force along the string, are directed towards the center of this vertical circular motion only at the 2 points, that is at the uppermost point A and the bottommost position B. Now, if you consider any arbitrary position between this uppermost position and the lowermost position, some part of the resultant, it is tangential to this circular path. So suppose I have taken the arbitrary position at point E. So we have to resolve this mg component to its two axis. One is the mg cos alpha, which is directed away from the this tension T1, which is directed towards the center, and second component is mg sine alpha, which is tangential to this vertical circular motion. Suppose I have taken any arbitrary position at point F. So here also we resolve this mg component into its two perpendicular axes. One is the mg cos theta, which is along the tension force T2, and second one is mg sine theta, which is tangential to this vertical circular motion. So in this way, at all other position, a part of resultant, that is mg sine theta or mg sine alpha, is tangential to the vertical circular motion and is used to change the speed of the vertical circular motion. And the tension components, which are directed towards the center, are used to change the direction of this vertical circular motion. A vertical circular motion controlled by only gravity. Here we are going to consider a second case, mass tied to the rod which is performing a vertical circular motion. So consider a bob tied to the rod and whirled along a vertical circles. Here, whatever the bob we have taken, that should be considered as a point mass, and the rod should be practically massless and rigid. So suppose this rod tied to the bob performing a vertical circular motion as shown in figure. So basic difference between the rod and the string is that the string need some tension at all the points including the uppermost position, and thus for the certain minimum speed at uppermost position is always given by VA is equal to square root of Rg. But in the case of rod, as the rod is rigid, the condition is not necessary and we can get the uppermost position, the velocity of the rod becomes 0. So practically the speed is 0 at uppermost position in case of rod performing a vertical circular motion.